All right, let's begin with the class. Inshallah, we are going to understand the second category of differentiation, that is differentiation of parametric equations. A very simple category. The only thing is the usage of chain rule, which we have already covered in AS level. Up till now, whenever we were looking at equations, the equations were of the form y equals to fx, where y was expressed as a function of x, and we used to differentiate it to get dy by dx. And we have learned several rules of differentiation up till now. In the last category, general category, we have covered a lot of different differentiations. And the simplest one that we covered in AS level was this algebraic differentiation. 2x cubed minus x squared becomes 6x squared minus 2x. The bottom line is, up till now, we always looked at functions like these, in which y was expressed as a function of x, and then we used to differentiate and get dy by dx. What is change in differentiation of parametric equations? Now you will be given two different equations. Y will not be expressed in terms of x. Rather, x will be expressed in terms of a perimeter. Y will also be expressed in terms of a perimeter. And then using the chain rule, you are going to connect x and y, and you are going to obtain dy by dx. So over here, a perimeter will be involved. So let's suppose if the perimeter is t, at times the perimeter is t, at times the perimeter is theta. So the examiner can involve any letter as a perimeter in that particular question. So let's suppose if the perimeter is t, then how will the information be given to us? We will be given x as a function of t. We will also be given y as a function of t. And then we will be told to find the gradient function dy by dx. So when y was expressed in terms of x, the gradient function was also in terms of x. And now because x was expressed in terms of a perimeter t, and y is also expressed in terms of a perimeter t, so the gradient function will also be expressed in terms of the perimeter t. It's very, very common sense. It's a basic common sense. So what we have to do, if x is expressed as a function of t, we have to differentiate x to get dx by dt. So if we differentiate x with respect to t, we are going to get dx by dt. If you are going to differentiate y with respect to t, we are going to get dy by dt. Then how do we get dy by dx? The chain rule tells us that if we want to find dy by dx, we have seen this chain rule over here. Dy, for the first fraction, the numerator is dy. For the second fraction, the denominator is dx. And over here and here comes one common variable. In this case, it's t. So we have taken dt on both the sides. Dt is the denominator of the first fraction and the numerator of the second fraction. So dt is taken. So if we are going to cancel dt, then we are going to get dy by dx on the second side as well. So the equation remains balanced. So we know how to make chain rule, right? But over here, we don't have to actually make chain rule every time. We just have to remember that for finding dy by dx, we have to do dy by dt into dt by dx. But we don't have dt by dx, we have dx by dt. So if we convert this multiplication sign to division sign, then this dt upon dx will become dx by dt. So the bottom line is, and this can always be used in questions. Whenever we need gradient function, we divide dy by dt by dx by dt. This means if y is expressed in terms of a perimeter, we differentiate y first, then we differentiate x. We can differentiate any of them first, but if we differentiate y with respect to t, and if we differentiate x with respect to t, and if we divide dy by dt by dx by dt, then we'll get dy by dx. So now this is something that we need to use in questions. The dy by dt will be in terms of a perimeter, dx by dt will be in terms of perimeter, and dy by dx, after dividing both, we'll get dy by dx. That too will be in terms of perimeter. We'll understand it better if you look at one of the examples, which is a passable question only for your concept clarification. How do we see what kind of questions come in exam involving the parametric equations, right? So let's look at it. Very simple example. X is equals to 2t squared plus 4t and y equals to t cube minus 5t squared. So x is equals to 2t squared plus 4t and y equals to t cube minus 5t squared. And in part number 1, we are told to express dy by dx in terms of t. So if we express dy by dx in terms of t, how can we do that? So we are told to find dx by dt first and then dy by dt, and then divide dx by dt by dy by dt. dy by dt will be divided by dx by dt and we'll get dy by dx. So dx by dt will be 2t square becomes 4t and 4t differentiated becomes 4. 2t square plus 4t. So dx by dt is 4t plus 4. If y is t cube minus 5t square, the dy by dt will be 3t square minus 10t. Then if we want to find dy by dx, then dy by dt divided by dx by dt, and we'll get 3t square minus 10t upon 4t plus 4. The gradient function is also in terms of perimeter. Bottom line क्या है? दो parametric equations दिए हुए होंगे, x भी in terms of a perimeter होगा, y भी in terms of a perimeter होगा. हम x को अलग डिफरेंशिएट करेंगे विद रिस्पेक्ट टू पेरीमीटर, y को अलग डिफरेंशिएट करेंगे विद रिस्पेक्ट टू पेरीमीटर, और y की जो डिफरेंशिएशन है उससे x की डिफरेंशिएशन को डिवाइड कर देंगे, तो हमारे पास ग्रेडियंट फंक्शन आएगा, और ग्रेडियंट फंक्शन भी इन टर्म्स ऑफ पेरीमीटर होगा. And if we have to find the value of the gradient, we'll have to substitute the value of the perimeter. So this was part number 1. In part number 2, we are told to find the gradient of the curve at the point for which t is 2. Now, if we have been given the value of t, we can find the gradient directly. But let's suppose if we are not given t and we are given x or y, then we can always put x and y in the given parametric equations to find the value of t first, and then we are going to put in the value of t to find the gradient. Because the gradient is dependent upon t, so even if the value of x and y is given, then we need to put back the value of x and y in the parametric equations given, and somehow or the other, we have to find the value of the perimeter t first, and then only can we get the value of the gradient, because the gradient function is dependent upon the value of the perimeter. And we have got dy by dx, right? Part number 2, the gradient of the curve at the point where t is 2 is very simple. We just substitute t equals to 2 in the gradient function that we have obtained. So 3 times 2 square minus 10 times 2 upon 4 times 2 plus 4 gives us negative 8 over 12, simplified to negative 2 over 3. The gradient is negative 2 over 3. The part number 2 is also solved. In part number 3, we are told to find the equation of the normal to the curve at the point where t is 1. So we all know that in AS level, we used to find the equation of tangents and normal. To find the equation of the tangent, we have to find the gradient by substituting the value in the gradient function. The value of dy by dx, the value of dy by dx will give me the gradient of tangent to the curve. And using the coordinates, I can find the equation of the tangent by using the formula y minus y1 equals to mx minus x1. So we all know that tangent and normal are perpendicular to each other. So if this is a tangent to the curve, this will be the normal to the curve, and they are perpendicular to each other. So if we need the equation of normal, we will first find the gradient of the tangent. How to find the gradient of the tangent? We have been given the value of the perimeter. We are going to put it inside the gradient function to get the value of dy by dx. The value of dy by dx will be the gradient of tangent. This is what I've written in part number 3. If I substitute t equals to 1 in the gradient function, the gradient function will give me the gradient of tangent. M means gradient and T means tangent. The gradient of tangent will be negative 7 over 8. But do I have to find the equation of tangent? The answer is no. I have to find the equation of the normal. So we know that the gradient of tangent and the gradient of normal, the product of both is negative 1. Why? Because they are perpendicular to each other. So the product of both the gradient is negative 1. Using this fact, or we can directly recall the concept of negative reciprocal. From this fact, we know that the gradient of one is the negative reciprocal of the gradient of the other. So if the gradient of tangent is negative 7 over 8, the gradient of normal is going to be 8 over 7. This means it is going to be a negative reciprocal. Negative reciprocal means the numerator, it will be reciprocated and the sign will also change. So as we have seen, the minus sign becomes the plus sign and 7 over 8 becomes 8 over 7. So there are two things that are involved. It's a negative reciprocal. Negative 7 over 8 becomes 8 over 7. Now, once we have found the gradient of the normal, we also need the coordinates of a point. But do we have the coordinates of the point? No, we don't have. But we have the value of the perimeter. So if you are going to put in the value of t inside the equation, we'll get x from here, then we'll get y from here. Once we have x and y both, then we will be having the point. We will be having the coordinates of one point, and we will also be having the gradient. So we can use the formula of equation of the line to find the equation of normal. So we can see that when t equals to 1 is substituted over here, it's 2 plus 4, the x is 6. If 1 substituted over here, 1 minus 5 is minus 4. The point is 6 comma negative 4. The gradient of normal is 8 over 7. the equation of a line is y minus y1 is equals to mx minus x. Then we can give the equation in any particular form. Over here, I've chosen the form ax plus by equals to c. So y plus 4 multiplied by 7 gives 7y plus 28. 8 multiplied by x and 6 is 8x minus 48. If you're going to rearrange, we can give in any particular form. If no form is specified, the answer can be given in any particular form. However, if there's a particular form specified by the examiner, then we will have to follow that particular form. So this is the solution of entire example number 1. The concept of parametric equations has been delivered along with one past paper question as well as an example. So just copy it down and let me know if it's clear to everyone. If you're clear with everything that has been taught up till now, just write. And also you have copied it, then write clear and done so that I can move forward towards the second example. Okay, so that's clear. Moving forward toward the second example. The parametric equations of a curve are x equals 2 theta plus sine 2 theta. Always remember that because we are dealing with differentiation, even if we are going to deal with integration in future, trigonometry and logs are the foundations. Trigonometry is very, very commonly used in questions. And over here, we have to do the same as the equation that now we are seeing is a trigonometric equation. Therefore, we will be differentiating it. And then at the end, the examiner is asking us to show that the dy by dx gets simplified to tan theta. This means the skills of trigonometric identities is going to be applied over here. So if we talk about the parametric equations of a curve, then x is equals to 2 theta plus sine 2 theta is one of the parametric equations. Y equals 1 minus cos 2 theta is another equation. And we have to show that dy by dx gets simplified to tan theta. So the first step, we are going to differentiate x with respect to theta. So dx by d theta, 2 theta gets differentiated to 2. Sine 2 theta, we know that when we are dealing with trigonometric functions, we deal with in the order power, function, and angle. So sine 2 theta gets converted to cos 2 theta, and then the differentiation of angle is 2. Cos 2 theta into 2. So 2 plus 2 cos 2 theta is the answer of dx by d theta. Then if we are going to differentiate y with respect to theta, then dy by d theta, differentiation of 1 is 0. Minus cos 2 theta, we know that minus will remain minus, but the differentiation of cos 2 theta is negative sine 2 theta multiplied by 2. This minus and minus will get plus. So this is going to be plus 2 sine 2 theta. So dx by d theta, dy by d theta. We have got both. Then we need dy by dx. For that, we are going to divide dx by d theta with the dy by d theta will get divided with dx by d theta. So 2 sine 2 theta divided by 2 cos 2 theta plus 2. Then we have to reduce it to tan 2 theta. So now we know that there's double angle formula involved. Sine 2 theta, the double angle formula is 2 sine theta cos theta. As far as cos 2 theta is concerned, we have three versions. One version involves cos and sine both. One version involves purely sine. One involves purely cos. Now, which version to use? Which version to use? There are three versions. Usually, we don't use this version. Either this is used or this is used. Now, we always need to remember what we have to show. So as we have to show tan theta, and tan theta is basically sine theta divided by cos theta, right? Dy by dx is tan theta, which means it's sine theta divided by cos theta. So this means in the denominator, we need cos theta. Always have an eye on what we need to show. As we need to show tan theta, therefore we need sine theta in the numerator and we need cos theta in the denominator. So as we need cos theta in the denominator, this simply means that we are going to use the double angle formula of cos 2 theta, and we are going to take the version in which the cos is involved. I repeat, because we need tan theta, and tan theta is sine theta over cos theta. So this made us feel that in the denominator, there has to be a cos theta, and that is why the double angle formula for cos 2 theta should be the one in which purely cos is involved. So cos 2 theta is 2 cos square theta minus 1 from the formula sheet. Then we have simplified it to get 4 sine theta cos theta upon 4 cos square theta minus 2 plus 2. We minus 2 plus 2 got cancelled. Then 4 got cancelled. Cos theta cos square theta got cancelled. Sine over cos was left. And then we have converted to tan theta successfully. In the explanation, this was the second example. And alhamdulillah, the explanation of parametric equations has been covered. Just copy it down and write clear and done, so we can move forward towards the past paper questions. All right, alhamdulillah, everyone is clear till here, and they have copied it as well. So now we are in a position to move on towards the past paper question, right? The two questions that we have covered in examples were also the past paper questions, but those are not a part of our current compilation. Those are old past papers. So we have covered two examples from past papers only. So we are going to cover more past papers now, inshallah. So the first question, the parametric equations of a curve are x equals to t over 2t plus 3. Now, please remember that whatever we have covered in the general category will be used. Whatever has been covered in the general category will be definitely used. So we have covered in the general category, we have covered the differentiation of exponential equations, the logarithmic equation, the trigonometric equations. Then we have seen that if we have to differentiate a product, then we use product rule. If you have to differentiate a quotient, we use quotient rule. So every such concept that we have covered in the general category is going to be used. So the parametric equations of a curve are x equals to t over 2t plus 3, y equals to e power negative 2t, and we are told to find the gradient of the curve at the point for which t is 0. So very, very simple question. If we are going to differentiate x with respect to t, then we know that as x is a quotient, right? It is a division. Two expressions are being divided. So quotient rule is going to be used. And quotient rule is that if you are going to differentiate u over v, the formula would be vu prime minus uv prime over v square. And this is already given in the formula sheet, so there's not a big deal for us, inshallah, because it's given in the formula sheet as well. I think I've shown you as well, but in place of u prime, it was du by dx. In place of v prime, it was dv by dx. But this is the formula of u upon v differentiating, right? Vu prime minus uv prime over v square. So x equals to t over 2t plus 3. We are going to use it differentiated using quotient rule u over v. Then it's vu prime. V as it is copied, the differentiation of t is 1. Vu prime minus uv prime. So u is t and v prime is 2. Vu prime minus uv prime over v square. So 2t plus 3 whole square. 2t and 2t got cancelled. We have got 3 over 2t plus 3 whole square. This is dx by dt. Then we know that if we differentiate the exponential function gets copied as it is, and the differentiation of power is multiplied. So if it is e power negative 2t, then the differentiation is going to be e power negative 2t multiplied by minus 2. The differentiation is minus 2 e power minus 2t. If we need to find the gradient of the curve, then we first find dy by dx. For dy by dx, dy by dt divided by dx by dt. So minus 2 e power minus 2t divided by 3 upon 2t plus 3 whole square. You don't have to simplify any further. We just need to find the gradient of the curve at t equals to 0. So we are going to substitute t equals to 0 in the gradient function dy by dx. And if we are going to substitute 0 over here, e power 0 is 1, so it's negative 2. And then over here it's 3 over 9. And we have simplified to get the answer negative 6. So I think this was a 5-mark question and very, very simple. And you people must have been able to understand it quite well, right? So you people don't have the passable file as of now. I'm going to upload it later, inshallah, tomorrow, hopefully, before the next class, so that you people are able to attempt the questions as well. As of now, you can take a screenshot of whatever is being covered so that we can cover more questions in lesser time, inshallah. Yes, so is it clear to everyone? Is question number 1 clear? Just acknowledge if you are clear so that we can move forward. Okay, great. Everyone to give an acknowledgement of clear, because you are not writing it down, so the acknowledgement will now be mentioning clear only. Okay, perfect. Everyone clear? Okay. Moving on towards the second question. The parametric equations of a curve are x equals ln tan t and y equals sine square t. And t lies between 0 and pi by 2. Because over here trigonometric function is being involved, so we have been given the domain that t lies between 0 and pi by 2. Now part number 1 says express dy by dx in terms of t. We have to express dy by dx in terms of t. So first we are going to differentiate y. First we are going to differentiate x and then y, and then we divide dy by dt with dx by dt. So I think it's a simple process. The only thing is we need to recall all different differentiations that we have done. So if we recall this sine square t, we know the order. It's power, function, and angle. So firstly, we are going to deal with the power. Also, we know that if we are differentiating ln fx, then the answer is f prime x upon fx. Only if we remember that we have covered this. When ln of a function is differentiated, the function comes in the denominator and the differentiation of the function comes in the numerator. So it's f prime x over fx. So this means that the function was tan t, it will come in the denominator, and the differentiation of tan t will come in the numerator, and that is sec square t. We have written sec square t over tan t. Then if we are going to differentiate dy by dt, or we have got dx by dt, but we have got sec square t over tan t. But if we need, uh, although over here it's not written that we need in terms of sine and cos. Had it been written, then we would have simplified. Over here, if we, even if we do not simplify and give it in any other terms, then also it can work because it's not mentioned. But usually at times we have to show and simplify it. So for simplification, we need to convert into sine and cos. So I've already done this over here, and also the answer in the examiner report is 2 sine square t cos square t. So if we need to align with this answer, then we need to work and simplify further. Although over here in the question, it was not specified to simplify in any particular form, so we could have left it like this as well. But and our answer could have been an equivalent answer given in the marking scheme. But over here, if we simplify, then how will we simplify? We know that sec square t is 1 over cos square t divided by tan t, which is sine over cos. Then division gets converted to multiplication, cos over sine, cos and square got cancelled. We are left with 1 over sine t cos t. Then if we differentiate dy by dt, then power function angle. So 2 multiplied, it's 2 sine t. Then differentiation of sine t is cos t, and then differentiation of t is 1. So 2 sine t into cos t into 1. The answer is 2 sine t cos t. So we have got dx by dt first, then we have got dy by dt. Then if we want dy by dx, we are going to divide it. dy by dt, dy by dx is dy by dt divided by dx by dt. If you are going to divide, the denominator will be multiplied with this numerator. The denominator of the fraction in the denominator. There's a fraction in the denominator, and the denominator of that denominator will be multiplied with the numerator, right? So this is going to be 2 sine square t cos square t. So the gradient function was to be found in terms of t, that we have done. Now, if we have to find the equation of the tangent to the curve at the point where x is 0. Now look, we have not been given the value of the perimeter t over here. Had we been given the value of perimeter, we would have substituted it directly in the gradient function to find the gradient of the tangent to the curve. But we have been given the value of x. So we are not given the value of t. But the gradient function is dependent upon the value of t. So unless and until we are going to substitute the value of x in the given parametric equation, and we are able to find t, if we are not able to find t, will not be able to find the gradient. So firstly, we are going to put the value of x in the parametric equation of x, and then from there we are going to get the value of t, and that value of t that we are going to get will be substituted in the gradient function to give us the gradient of tangent to the curve. And then that value of perimeter will also be substituted in the second parametric equation to give us the y coordinate of that particular point. Because for equation of tangent, we need the value of x, we need the value of y, we need the value of gradient. So everything is very, very basic. We just need to recall, we just need to keep ourselves very alert as to what needs to be done, right? So x0 substituted will give us t. T substituted in the equation of the substituted in the parametric equation of y will give us y. T substituted in the gradient function will give us gradient of tangent. So, but the first thing is to get out of it. If we are going to substitute 0 in place of x, how will we find t? So the process is we are going to convert from log form to index form. The process I have done over here, x, the parametric equation of x, in place of x I have written 0. Then ln tan t equals 0. Then ln means log with the base of e. So log of tan t with the base of e equals 0. Then this e is the base. If we convert from log form to index form, then e is the base and 0 is the power. So tan t is equals to e power 0. E power 0 is 1. So this step was related to logarithms. And then after we have got this step, tan t equals 1, then we are going to involve trigonometry. Tan of an angle is positive. Tan of an angle is positive in which two quadrants? So it's positive in the first quadrant and the third quadrant. Tan of an angle is positive in the first quadrant and the third quadrant. Right? Tan of an angle is positive 1. It is in the first quadrant and the third quadrant. But we are only going to focus on the first quadrant. Why so? Why are we not focusing on the third quadrant? What is the reason behind that? Because of the given domain. We have been given by the examiner that t lies between 0 and pi by 2. T lies between 0 and pi by 2. So if t lies between 0 and pi by 2, this would mean that we are going to focus on the first quadrant only. In the first quadrant, angle equals basic angle. So if we are going to find the basic angle, that is going to be tan inverse 1, which is going to be pi by 4. And the t is going to be equal to alpha in the first quadrant. And that is why t over here is pi by 4. Now, once we have got the value of t, we are going to substitute that in the parametric equation of y. As we can see, the parametric equation was sine square t, which means sine t whole squared. So this is what I've done, sine of pi by 4 whole squared, and I've got 1 over 2. Then this t by 4 will be substituted in the gradient function. 2 sine pi by 4 whole square cos pi by 4 whole square, and we have got the gradient, that is 1 upon 2. So we have got the value of x, that is 0. We have found the value of y. We have found the value of gradient. Y minus y1 equals to mx minus x1 will give us the equation of the tangent, and that is y equals to half x plus half. With this, I've completed question number 2 as well, with all the concepts, I guess, explained in a well-defined manner. Just let me know if everyone is clear till here. Is this example clear to everyone? Yes, I can definitely solve the question. Done. Alhamdulillah, everyone is clear till here. Alhamdulillah. Okay, so what we have done, we have understood the parametric equations, how to differentiate parametric equations, right? And then we have covered the possible questions as well. And I have more possible questions as well, inshallah, that the recordings of which will be uploaded on LMS. So I think we should keep our class restricted till here only, because we have covered the category of differentiation of parametric equations. We have covered 2 questions. Then I have a lot of other questions as well. So I'll upload the possible file. You are going to print that file. And after printing that file, you're going to attempt the questions. And then if you're going to get stuck up in any particular question, then I am going to upload few recordings as well of the possible questions of parametric equations. And inshallah, you'll be able to deal with that. In the next class, inshallah, we are going to cover the implicit differentiation as well. And then once our second class ends, then you will be attempting parametric and implicit more during the week. And in the next week, inshallah, we will be resolving the problem of those as well. If someone has not done the differentiation general category, that can also be done. And inshallah, now what I've planned is whatever recordings I have of past paper questions in the past that I've covered, I'll just be uploading that. जो सवालात मैं करवा चुका हूँ पास्ट पेपर के अंदर पहले पुराने, उसको हम इस्तेमाल करेंगे इंशाल्लाह, और उसको यूटिलाइज करते हुए जो है वो हमारी पेस भी बढ़ जाएगी इंशाल्लाह, because बहुत लेंदी कोर्स है, lot of things have to be covered. So just to increase the pace, it's very essential that I share recordings of the past paper questions specifically, because the explanation I'll be covering live, and I'll be covering few questions as well live. But for few more past paper questions, I'll be uploading the recordings for our process to increase, for the pace to increase, right? So I think we should not move any further. I'll upload the past paper file, print those first, and then attempt the questions, and then if you have any queries, then bring in the next class, inshallah. And once if the queries are resolved, then we can move on to the second category of the third category of differentiation, which is the last one, inshallah. So I think it's more than enough for the today's class. And see you in the next class. Have a good day. Take good care of yourself. अपना बहुत सारा ख्याल रखिएगा. मुझे दुआ में याद रखिएगा. अस्सलाम वालेकुम व रहमतुल्लाहि व बरकातुहू.